Good afternoon, everyone, and welcome. I think now all the presenters are here. We can start the session. My name is Glenn Hunt, and I'm from the Mountain Research Initiative in Geo Mountains. And on behalf of the organizers, I'd like to thank you all for joining us for this community event on addressing data gaps and capacity needs for land restoration and land degradation neutrality in mountain regions. This session is jointly organized through collaborations between Geo Mountains, Geo LDN, WOCAT, CBAS, ICMOD, and colleagues from the Mountain Research Initiative and the Center for Development of Environment at the University of Bern. Mountain regions are critically important for biodiversity, water security, carbon storage, and livelihoods. They support hundreds of millions of people directly while also providing essential ecosystem services far beyond mountain regions themselves. At the same time, mountain systems are highly vulnerable to climate change, land use change, biodiversity loss, and environmental degradation. Yet despite their importance, mountains remain among the most challenging environments for monitoring environmental change through Earth observations and global monitoring systems. Part of this challenge is technical. Mountain environments are inherently complex landscapes. Steep terrain, cloud cover, fragmented land use systems, and shadow effects all create difficulties for satellite-based analysis and interpretation. Compared with flatter and more homogeneous landscapes, monitoring environmental change in mountain regions is often much more complicated. But there are also deeper conceptual and interpretive questions that emerge when we think about land degradation and restoration in mountain systems. At first glance, monitoring degradation from satellites can appear relatively straightforward. Areas become greener or browner, forest cover increases or decreases. Vegetation productivity changes over time. However, mountain landscapes often challenge these assumptions. Many mountain systems are highly dynamic and multifunctional. Land use practices, seasonal variability, forest regeneration cycles, pastoral systems, and rapidly changing socioeconomic conditions can complicate how environmental change appears within Earth observation datasets. In some cases, the same landscape may be interpreted very differently depending on the indicators, classifications, or scales being used. These questions matter because Earth observation-derived indicators increasingly informed SGD reporting, land degradation neutrality assessments, restoration planning, investment priorities, and broader environmental governance processes. At the same time, we also want to emphasize that Earth observation has transformed our ability to monitor environmental change globally and offers enormous opportunities for mountain regions. Across MRI and Geo Mountains, much of our work focuses precisely on improving the discoverability, accessibility, integration, and usability of mountain-relevant data and information. This includes activities such as strengthening mountain monitoring inventories, supporting regional workshops and capacity-building processes, contributing to scientific and policy discussions around mountain observations, and helping connect researchers, practitioners, and policymakers working across different mountain regions globally. One of the important points that emerge from this work is that monitoring challenges are not only about satellite imagery itself, they're also about governance, institutional coordination, interoperability between datasets, long-term monitoring infrastructure, and the ability of different communities to access, interpret, and apply information meaningfully within specific mountain contexts. So the aim of today's session is not simply to identify gaps, but to explore both the opportunities and limitations of current approaches and to discuss how Earth observations can be better combined with field-based observations, local and indigenous knowledge, and contextual understanding to support more meaningful assessments and decision-making in mountain regions. Just briefly on the structure of today's session, as there have been a couple of changes. We will begin with a series of short presentations. First, Alex Massot. See if this works. That's me. First, Alex Massot from Geo Mountains will introduce some of the broader work of Geo Mountains around the monitoring gaps observations infrastructure, data accessibility, and governance frameworks. We'll then hear from Professor Xiaosong Li from CBAS, who will present work on SDG Indicator 15.4.2b, drawing on China as a case study and highlighting methodological challenges and opportunities for mountain-specific monitoring. And then Virendra Bhattacharya from ICMOD will share perspectives from the Hindu Kush Himalaya, focusing on regional data services, applied analytics, and decision-supporting tools for mountain environments. Finally, Tatenda Lemon from WOCAT will present existing approaches to assessing land degradation and restoration in mountain regions. If I could invite the four presenters to please come up and sit here? There they are. Following the presentations, we will move into a moderated panel discussion, and we hope to have time for some audience questions as well. But with that, I think I'd like to hand over to Alex Massott from GeoMountains, and the floor is yours.
Thank you. So hello, everyone. I will shortly introduce GeoMountains and our activities, and especially two tools that we use and that can be relevant for land degradation neutrality. So first, is it working? Okay. So first of all, maybe just a short, really brief introduction on why mountains matter for LDN. It's about 25% of the Earth land surface represent mountains, and it's home to 1.1 billion people. It hosts critical ecosystem services, and such as, for example, the first fruit of 50% of the global population, biodiversity hotspot, and it does regulate climate. It is particularly fragile ecosystem, and climate change impacts twice faster than global average. And mountains are transboundary in nature, so about 40% of mountain area cross international borders. This is why international cooperation is essential. But there are really important data gaps in mountains, and monitoring infrastructure are usually much more sparse than in the lowland areas. So this is a bit our mission with GeoMountains. So GeoMountains is the global network for observation and information in mountain environments. It is a group on Earth observation work program initiative co-led by the CNR and the Mountain Research Initiative since 2016. And our aim, as Glenn briefly mentioned them, are to increase the discoverability, the accessibility, and the usability of a wide range of data pertaining to mountains globally. But we also aim to integrate and apply such data and information for scientific, policy, and practical impacts. And finally, we tend also to build, connect, coordinate, but also share capacity across a wide community of mountain researchers, practitioners, and policymakers. Oops, sorry. Our project is part of the Adaptation at Altitude program, which is funded by the Swiss Agency for Development and Cooperation. And we are now in the second phase of the program, which is from 2024 to 2027. We focus mainly on 5 regions, which are the Andes, East Africa, the Hindu Kush Himalaya, the South Caucasus, and Central Asia. So just to give you a short introduction on our main activities, we do develop and maintain inventories of long-term mountain measurements, sites, and also created data set and data portals. So we have an in-situ inventory, which I will briefly introduce later, and a general inventory. But we also try to convene members online and in regional workshops to share challenges, solutions, and best practices around monitoring. And we also contribute to scientific debates and activities on mountain monitoring and data generation, observation, and essential variables for mountain system, for example. And finally, we also do provide mountain data and information in formats that supports global assessments, such as the IPCC and different policy process. So to briefly explain about the first tool that can be quite relevant for LDN. It is the in-situ inventories, which basically answer the question, what is monitored where? And the GeoMountains in-situ inventory is a global comprehensive catalog of ground-based monitoring programs, which operates in mountain regions worldwide. So it does document what is being measured, where, by whom, and how. And this provides a critical foundation, of course, for validating remote sensing products, but also to strengthen national LDN reporting. So the main challenge is that mountain monitoring is fragmented. It is often made in isolation and with inconsistent methodologies. And our approach is really to facilitate the harmonization and interoperability by providing a shared platform for these measurements. So what it contains is only metadata, but records of monitoring sites, parameters that are measured, institutional ownership, temporal coverage, and we also indicate if the data are accessible or not openly. So it has been updated in September 2025. And this last update introduced several major developments. So for example, the coverage has been expanded. There is more station and more network present. We can also see the network association. So each station is now explicitly linked with the wider network that it belongs to. And we also can see the mountain range attribution for each of the station. So it is possible to make a search by mountain range as well. And the second tool I wanted to briefly introduce is the specialized multilateral environmental agreements database. And this aims to answer what governance framework exists for which mountain region. The aim is really to understand which international legal framework supports mountain protection and where governance gaps exist and how countries engage with these MEAs. These questions are critical to advance global commitments such as the SDG 15.4 on mountain ecosystem and climate adaptation strategies more generally. Thanks. It does support policy integration. So it enables evidence-based advocacy by showing where existing treaties can be leveraged for mountain regions. It reveals governance gaps as well by identifying which mountain region have stronger legal framework coverage and which lack mountain-specific agreements. And it facilitates also transboundary cooperation. So it maps which countries share commitments under specific MEAs and supporting coordinated action. So what it basically offers is, here you can see it. Yeah, just add a screenshot here. I don't really have time for a demo, but you can find, of course, the in-situ inventory and this data set also on our website. And this one integrates metadata from over 1,400 MEAs. These are all sourced from the International Environmental Agreement Database, which is hosted by university level. So it's a very comprehensive catalog of all MEAs. And we added the global mountain delineation and country level spatial data for each of these MEAs to be able to visualize it in a more user-friendly tool. So each MEA has been systematically classified as well into 3 levels of classification, depending on their mountain relevance. So the key feature is that you can see and visualize these 1,400 MEAs. There is also geospatial layers available for each MEAs showing signatory countries. And for the level 1 of which represents 25 mountain-specific agreements, there is also specific coverage for these ones. And you can also find some country-level statistic on MEA participation. So here is just a map to show you an example of what you can do with the database. And it shows the 25 level 1 MEA, so the mountain specific. Okay, I finish real quick. But basically you see the 3 main ones are the ones that are also relevant for LDN. It's the global agreements that does mention mountains in their text. So we have the Convention to Combat Desertification, the United Nations Framework, Convention on Climate Change, and the Convention on Biological Diversity. And the other ones are more regional agreements. So just some very short key takeaways. Mountains are critical for LDN, but they do remain under monitored in many regions. The data infrastructure matters, so the in-situ inventory is a good example, and it does reveal monitoring gaps and supports coordinated observation. There is also a lot of governance frameworks that exist. and the MEA database can help in showing them. And in general, we also need to combine monitoring data with policy analysis to enable strategic action. Okay, thank you.
Great, thank you, Alex. I'd now like to, round of applause. I'd now like to invite Professor Xiaosong Li from CBAS. Thank you, the floor is yours.
Okay, so firstly, thanks for the invitation of the study event, the organizing committees. So I'm very pleased to join this important study events to give a case study about how the CBAS fill the data gap about the mountain areas, about the land degradation, the neutrality. So we focus on the indicator about SDG 15.4.2b, a new indicator just proposed in the 2023. So the content including the following the parts. Firstly, we could see the mountain axis facing the increasing the degradation pressures from multiple sources, making it necessary to establish an indicator for monitoring their conditions. So this indicator was proposed in the 15th session of the United Nations Statistical Commission in the 2023. And the definition of the indicator we could is about the degradation of the mountain ecosystems caused by the human-induced declines or loss in the biodiversity, the ecosystem functions, or the ecosystem services. I think this is the definitions. And the challenges for reporting this indicator, I think, could be summarized in the following parts. Firstly, we know a series of studies for the SDG 15.3.1 about land degradation has been carried out in the past decades. But for now, the no systematic assessment specifically targeting the degradation indicators for mountain ecosystems. In fact, we also have the other degradation problems in the big category of the lands, but they have their own specific characteristics. And in the method, the calculation, the measures only depend on the land cover change, which carries a risk of the subjectivity. I think this is the main problem. And also in mountains regions with significant topographic variation, the use of the product area instead of the surface area in the area the indicators may lead to the biased results at the different scales from the national to the provincial or to some of the local scales. And finally, we still only have the nation level indicators, and I think it's far from sufficient. And more especially explicit and fine-scale assessment needed. And for our study, the objective is we take China, the mountain areas as the pilot, the areas. Only 2 minutes. Yes, we try to focus, estimate the SDG, the indicator, the 0.4.2b in China to understand the pattern. And also we try to analyze the influence of the human activities and the natural disturbance. And so the key technologies, I think, including the revised calculation method from the SDG 15.3.1. Another one is the spatial triangular surface area calculation based on the 3+3 pixel. I think this is very important. We use the land cover, the annual growing season, and the soil organic carbon date in China at different spatial resolutions. Also, another dates were used. Our main findings is from the 2015 to 2022. The mountain area shows the restoration trend. The net soil areas reached to the 0.69 million square kilometers. And subnation zoning, the indicator could reflect spatial difference of the different mountain types. I think we have the 6 the mountain types. And about the driver analysis, we find temperature, the precipitation, and the gradient intensity are the major factors on the mountain degradation. Also, we found the elevation contributes higher and the aspects, while the population the contributions equal to the GDP. And the final slide is the next step. I think firstly we need to focus on the mountain-specific enhancement of the identification monitoring. And second, we should monitor the accident function and disaster risks in the mountain areas. And finally, the high-resolution monitoring use multi-source data and AI could be employed to improve the accuracy and the spatial resolution. That's all. Thank you very much.
Thank you, Professor. Just a quick note to presenters, the pointer mechanism is actually over here. So when you point up this way, I see you're pointing over there. Next, I'd like to invite colleague Birendra Bhattacharya. Sorry, I pronounced that wrong probably, from ICMOD. The floor is yours. Thank you.
Okay. Very good afternoon. I'll be presenting on our efforts from data to decisions, how to promote data availability, data sharing for the Indico-Himalaya region. Indico-Himalaya, if you look at it, it is formed with the 8 member countries of ICMOD, which is based in Kathmandu and formed under the UNESCO Charter back in 1983. This is also we call the third pole because of the 10 major Asian river systems and the largest storage of fresh water besides poles. And also it is one of the biodiversity hotspots. So within ICMOD, we have an intervention called Regional Information Service, which is mainly looking after making the data available and accessible, and also how to promote the analytics so that we have better understanding of the different dynamic studies undergoing in the region. And also third component is on innovation, how we can really benefit from the emerging tools, technologies, and data sciences for better understanding and supporting decision. So under the data sharing initiative, we have a platform called Regional Database Service, where system where it supports all the data that is available or made available through ICMOD's different projects into one repository, and also with the standard metadata, and also with a lot of these tools to query and search the data. We hope that we are making the data sets available and then also accessible. In the last 4 years, we have seen more than 30,000 downloads by more than 7,000 unique users. So that also shows that there's an increasing use of our resources. And this is also made available through the Geo portal, Geos portal, so that we can make the data discoverable from multiple portals. So another pillar is on analytics and regional trends, where we are working on a system called SKS Regional Information System, where we are trying to bring in all the data sets that are relevant for climate change, human dimensions, ecosystems, cryosphere, physiography, disaster, and so on, so that the users can also have a kind of integrated view, visualization, and analytics of all these different phenomena. So far, what we have seen is we tend to confine ourselves on sectoral analysis, and then we normally tend to forget the relations that might have in different cross-sectoral themes. So one example on the land degradation here is the Enhanced Vegetation Index over the from 2000 to 2023, where you can clearly see how the degradation is taking place. And if you zoom in, you can see the big patch is Kathmandu Valley, and how within the valley and along the rivers, along the roads, there's a growing land degradation over the years. So similarly, we have developed a number of information services, mainly regional land cover monitoring system, which was developed under the survey initiative in the past, and also the national land cover monitoring system, which are based on Google Earth Engine, so that we can have more current land cover datasets prepared annually. We also worked on the forest type mapping for Nepal, and also with CBAS, we have collaborated in developing the SDG 15 indicators life and land for 3 countries, Nepal, Bangladesh, and Bhutan, so that we have consistent regional databases available for the indicator. Now, on the innovation side, we are again working with the Survey Global Collaborative, where again we are different survey hubs from East Asia, from South Asia is the Asia mode, then East Africa, West Africa, Amazonia, and South America, where we are again getting together to come up with the geo-AI-based global platforms, where ICIMOD is leading the land cover and environmental monitoring platform, which I think will be one of the major upcoming platform which will be relevant for the land degradation part. So finally, the science and innovation is very important, and for this, we really need shared expertise, shared data, and experimental capacity development, and so on, so that we can all join hands together, so that we can all benefit to come up with a system which can work for the benefit of all. Thank you.
Thank you so much. Lastly, we'd like to give the floor to Tatenda Lemon from WOCAT, CDE University of Bern.
Thank you very much. Thanks a lot, Glenn. And first of all, I would like to apologize that I'm here. I know my colleague Ingrid, with her actually would also have a certain gender balance, but warm regards, and I hope I can represent her properly here today. So I would like now to bring this whole topic a bit to a broader context on land degradation and show existing data and approaches to assess land degradation and also support the restoration. I think it's an important point that we are not only talking about where do we have the problems, but also what are the solutions. Before I start, I would quickly like to introduce where I'm coming from, actually, and what WOCAT is. So WOCAT is Global Network in Sustainable Land Management. The secretary is hosted by the University of Bern, the Center for Development and Environment, where I'm also based. But it is a consortium with these 7 consortium partners that you can see listed here, amongst other, of course, our colleague from ICIMOD, also GIZ, where we have a GeoLTN secretariat hosted as well. Many other partners. I don't know if we have someone from FAO in the room. And this network was already established more than 30 years ago, right after the Rio Conventions, and it supports the compilation, documentation, the evaluation, but also the sharing and dissemination, as well as the application of sustainable land management practices. And that's very closely related, of course, to the whole LTN discussion we have at the moment. And its growth actually culminated in 2014 to being the officially recognized database by the UNCCD as the primary recommended global database for best practice reporting, meaning UNCCD parties, the countries, can use the WOCAT database to report their best practices from the ground towards the convention and link it directly to the land degradation with the response hierarchy. But talking about the database, I would like to give you a quick insight in what it actually means. So it is a standardized multilingual database with a bit more than 2,000 good practices from all over the world. They're all documented together with land users and experts on the ground before they're going through a review process and being published, and then really provide these technical insights on how does it work, the good practice, what are the costs for the implementation, and also what are the impacts at all different levels on the state of sustainability. And I think we learned over the years that, of course, the easiest way to learn something is to learn from those who have done it. That's actually, we would like to make this knowledge available to also support replication and to also to facilitate the scaling then of sustainable land management by informed policies and incentive mechanisms. So we have different entry points to the database, as well as the additional modules on gender, on carbon benefits, on economics, and also based on the different ecosystem, you can find the good practices. And one of those ecosystems, of course, mountains. And you can filter then the good practices that are available for the mountain areas, as an example. And a few years ago, we made in Mountain Futures publication, we analyzed what good practices we have in the mountainous region so far to really understand a bit, okay, what is the need in these different regions and what land degradation types do we have and do we face? And just a brief overview, it showed that most good practices above 2,500 meters actually addresses biological degradation, which is often linked to overgrazing and climate change, while the lower areas, mountain areas, of course, due to the slopes, are mostly affected by soil erosion by water. But this knowledge is then not only available on the database and on linked publications, it can also be linked with other platforms, meaning through an application program interface. Once a good practice is published, it can then be linked to other platforms automatically, that those good practices that are actually restoration good practices also included then in the firms of the Framework for Ecosystem Restoration platform, which is also being used by UNCBD to report on restoration activities, or those who are relevant for drought or sand and dust storms are then linked to a drought toolbox or a sand and dust storm toolbox from the UNCCD, or a water harvesting explorer where you can find similar good practices based on your environmental condition, or just with the Great Green Wall Observatory, where then all the good Great Green Wall activities in the countries can also be shared and made available. But that's actually on a global and a regional level. Also on a national level, then we link it with national platforms, such as here the PhilCat, the Philippines, where the best practices then are made available, and also down to applications where, based on your location, on your needs, you might find the relevant good practices, based on, as an example, also with a chatbot that can lead you through some questions to find the good practices. But having talked a lot about actually the good practices, of course, it is always important to understand, okay, where do we implement them? Which are the good practices? And that's why we are all here today. So really to understand, okay, where are the best suitable areas in land degradation? We are discussing where do we try to avoid, to reduce, or to reverse land degradation. So first to see where can they be applied, where they have already been applied, where do we anticipate future land degradation, where is the worst degradation, to really go into this response hierarchy I just mentioned, to see which good practices are reducing or avoiding land degradation, reducing, or then restoring. And that's then, of course, key for all land use planning activities. But land degradation, I don't know who of you have ever discussed actually in the field what land degradation means. And if you ask then people, what does land degradation mean? Is this area degraded? You might get very different opinions. Of course, we are coming from different fields, and it is not so obvious often what degraded land means. And that's why it is really important that if you're talking about that, we need to have evidence-based discussion to understand what is the biodiversity angle, what is the land users angle, and perhaps what is the disaster risk reduction angle, and so on, to bring this expertise together in a participatory and inclusive way. And that then really enables to map land degradation if you reach consensus and if we all have somehow the same understanding of what land degradation actually means. I think those of you who have worked with land degradation, just looking, see quite many in this room, some more experts than I am. Land degradation mapping is not easy. I think you all agree. And often stakeholders disagree what I mentioned, what land degradation actually is. And maps produced by single experts, we also heard it this morning, often not really gain the ownership and trust that are needed to get used for national planning and also decision making. And that's why we apply, or we use this participatory multi-stakeholder knowledge management tools and platforms to really help to make the decisions what to do, where to invest and what to prioritize, that people understand why are we prioritizing this area. So not only see red, it is land degradation, but what type of land degradation it actually is. What does it mean for me and for the different audiences? So, and that's also nice to have such events as today. I think we have very different institutions coming together, working on this knowledge exchange to understand what it means. And just I mentioned before, a single data set might not be the very trustful. I can give you an example of this. The layers that can be used for reporting on SDG 15.3.1 on land degradation, and based on the different land productivity dynamic maps, the countries, the praise system is the UNCCD reporting program of the UN, so where countries can report on land degradation, and you can see those are all default layers. And it depends on what kind of land productivity dynamic map you are choosing. You can go with 7% global land degradation or 26%. So what does that mean for me if I have actually a red dot in my map? And there we also, together with the partners, we produce these applications to understand these Google Earth applications to go into the different maps and the different tool layers to see why is something green, and to do really then the ground truthing as well, and to have a joint understanding what it finally means. So over the past 20 years, actually, WCAT and its partners, we made a big effort to assess, together with the different experts, land degradation and to find related sustainable land management practices. And we have this mapping tool that has been further developed over the years, and together with the countries, and it's been enhanced then with Earth observation data to support and also the countries in reporting land degradation neutrality towards the convention. And this knowledge was then not only made available within the countries, also all this experience was then shared in joint publications with the UNCCD and our partners. And finally culminated as well in an addendum of the good practice guidance there, where these participatory approaches are also included to guide the countries, the parties, how to document land degradation neutrality. And while we are also here, after the last CRIC of the UNCCD, we have, or during the CRIC, we have realized that several countries actually, with mountainous countries, they call the UNCCD, raised their interest to get additional capacity building, to get access to these land degradation layers. And so that's why it's really nice to be here. And we realize there is such a lot of information already here. And so we just need to bring it also together and to make this knowledge available. And this is actually a little bit on what you have discussed in the previous section already this morning. We have the different targets, even within goal 15. So 15.3.1 is really the proportion of land that is degraded over total land area. And the custodian agency is the UNCCD. And at the same time, we have, just before presented by Professor Lee, the proportion of degraded land in mountain areas. And this is then actually with FAO. So I don't know if those people or those experts who are reporting on these different indicators, if they have ever been in contact to see whether the land degradation in the mountainous regions are the same as have been reported by the expert or by the ministry reporting land degradation neutrality. I think I would very much echo what has been said this morning. This siloed approaches, I think, should somehow get overcome. And I think it's very nice, or perhaps we find some time in the panel discussion as well, if you have some experience, since you have all these different data available, how it can also be linked. I'm not going into detail here. I would just like to show that these participatory approaches we have developed together with the countries, the LTN decision support systems, where exactly this global data set, this Earth observation data can be linked with national knowledge. And we heard it this morning already. It is not enough for a country to have a global data set often. They need to have national and even local knowledge included as well to really take proper decision. And together with them, we have this Google Earth Engine applications, which then allow to discuss and to understand what is happening on the ground. And just as an example from Bhutan, where we have developed, we have looked into very different land productivity dynamic maps, together with these different ministries that have been mentioned, not only with one ministry who was reporting on 15.3.1, but to also have the soil services, the forest, the parks, very different interests coming together on one table to see where do we want to go, what does land degradation mean for them. And I do not find the time now, but in this apps, they also allow them to do in a multi-criteria analysis to compare or to see, okay, which mountain areas, where did we observe land degradation in the last reporting period? And we can go into these areas to see, is it based on the land use systems? What are the reasons behind? What is the land degradation type? It's not only about land degradation. What is the reason that land degradation is happening? And then linking again back to possible solutions. And I think we are very well positioned now. We really have a lot of available data. We heard it also from my colleagues this morning. We have more and more capacities with cloud computing, data mining. So this knowledge can be made available in a user-friendly and participatory way. And I think that really helps then to democratize the knowledge actually that is being generated and to co-develop knowledge in an inclusive way, that everybody's on a table and finally is reporting something that also makes sense for them personally. Thank you very much.
Thank you, Tatenda. I'd now like to invite our panelists to come up. And Alex, thank you very much. So, of course, we all know you from this morning, so welcome. So we'd now like to move to the panel part of the discussion. And Ajay, because you haven't had an opportunity to present, I think we'll start with you first. So I think in terms of geo-LDN, like mountains on the radar, how are you thinking about mountains? Because obviously land degradation happens, a lot of different ecosystems, mountains just one. So how do you approach that? Thank you.
Yes, thanks very much. Yeah, it's actually, it makes sense that I didn't present because the experts on the mountains are sitting here. Talking from the mandate that geo-LDN has, of course, it's a global mandate, and land degradation happens on all land surfaces, including mountains. And we are totally aware that we have some very challenging environments in terms of monitoring and reporting. These are hyper-arid areas where we are currently collaborating with the regional center on trying to set up solutions how to better monitor hyper-arid areas. We know the SIDS, so the small island developing states, they have specific problems which are mainly related to the resolutions. And we know mountains are the third challenging environment. So these are the really difficult parts. And when you see the land degradation maps of the global indicators, for sure you see some areas do not perform as well as others. And this is also why you have different when you use different approaches, you have different quality there. And I think this is, this is where we can really start collaborating more closely. With the UNCCD, the reporting works in a way that UNCCD provides through their partners default data to the countries. The countries have to assess the data sets. They are encouraged to use their own national data sets. And only if they are not able to do so, to use the default data sets, and then report this back to the UNCCD. There's a lot of flexibility in this, where we can learn from your research and from your practical work, I think. We have done a very little bit on mountain work, and Tatenda was referring to this. So we did this e-learning course together with UNCCD and FAO, which is hosted on the e-learning platform of the FAO. It's the e-learning course on using land cover information to monitor progress on SDG 15. And these are exactly the same indicators that Tatenda just mentioned, 15.3 and 15.4, because we see that the indicators, as Jörka from GeoWetland said this morning, the indicators are defined. We have political decisions, and this was a long process to define the indicators for the convention, so it's not easy to just change the indicators. But there's flexibility on how to measure these indicators. And I think this is where we need to go in there. And the many, as we also learned this morning, I mean, many conventions need the same data sets, and land cover is one very basic data sets that you need for biodiversity or for climate, for land degradation. And we know that for land cover, for example, in this GPG addendum of the UNCCD that Tatenda also referred to this morning, just now, there are some examples also of challenges in the mountains. For example, Colombia realized that they are missing a glacier and snow land cover class because they see that this is relevant, that glacier retreat and snow cover reduction is a critical degradation for them. So there's the flexibility to include this in the UNCCD methodology on how to measure these indicators. So not changing the indicator, but how to measure the indicators. So moving forward, just some reflections. I think we can build on the e-learning course that we started and see how we can support UNCCD and especially the country parties, of course, to improve the reporting in those difficult environments, including the mountains. Then, of course, we have 2030 just ahead of us. So the whole monitoring frameworks are being renegotiated. So can we have influence on aligning these indicators better? The devil is in the details. So the reporting periods are different. So for mountain indicator, I think it's 3 years. For UNCCD, it's 4 years. So that makes it hard for countries. So why don't we try to put some political force also on aligning these indicators? Also working on institutional collaboration on the countryside. We've talked a lot about it this morning already. We have Professor Lee sitting here from CBAS, who is also a co-lead of the GeoLD capacity development working group. And CBAS has a lot of expertise in mountain research. So that can also be a way of integrating that expertise into the work of LDN. Yeah, I think there are many opportunities, and I see this session as a very good starting point that we can collaborate more closely in order to improve the reporting of the countries and also to implement measures to improve land use.
Great, thank you so much. My next question, I'd just like to go to Professor Xiaosong. How confident, like we've seen on these presentations, how confident can we be that the current EO indicators accurately capture land degradation and restoration across mountain regions?
So thank you very much. So I think it's very difficult, the question. I think with the development of the open data science and the AI, the technology, I think the more and more the spatial products you could see every day, I think. So at the same time, you have so many data sets, but for the degradation, I think we have not so much the useful degradation data sets. It's about the definition, what's the degradation, how to transform the remote sensing the signal into the degradation variables. I think it's very important. And I think the current, the EO-based indicator is very important and useful, but it's far from the sufficient to evaluate the mountain systems, the degradation. We know the mountain system is very complex, with the topographic effects, especially when we use the remote sensing the data set. And generally we have a lot of work about the land degradation, the 15.3.1. That's the Tatanda's the questions. So there's a lot of the different the ecosystems, like the mountains, like the deserts, and the different the ecosystems. So now I think we just have a simple the indicators for the different countries to report to the constant agencies. We have the minimum indicators of the land degradation, the land cover change, the land productivity change, and the soil organic carbon change. This is the minimum the indicators. But I think with the development of the assessment, we realized we should have the more indicators, which should be the specific for the different the land covers, for the different the ecosystems. And now we try to develop the degradation variables for the hyper-arid areas and the arid areas. But I think for the mountain areas, it's a similar problem. Not all the indicator could reflect the mountains degradation or the restoration process. I think is very important. So for the future, I think we should build a network to combine the ground truth state and the degradation variables with the remote sensing the data set. I think is very important. But the key, the challenge is can we upscale all the field truth indicators to the remote sensing? I think is a big problem. I think some of the hidden or the subtle indicators, not like the obviously the land cover change, such as the productivity the decline, the biodiversity the loss, and some the hydrological the condition the change. All of this is very important for the mountain degradations. But for now, I think it's difficult to get these informations from the observation data. And in the future, I think combine all the data sets and develop a framework to upscale the degradation of variables from the ground truth to the remote sensing data is our future. Thank you.
Thanks. I wonder if we could now just skip over to Virendra. Of course, you're based in Nepal and doing a lot of work across the Hindu Kush Himalaya. And we saw a lot of this discussion about, interpreting what land degradation means. One person's degradation is some person's something else. But how do you think we can get local and indigenous land use knowledge to help interpret some of these EO observations?
Yeah, thank you. That is very important that we try to interpret a lot from the remote sensing, because we are also excited by the kind of analytics that we can bring in. But we see that local knowledge really brings that into context. The classification that we do that is really put into context. I can give you two examples, the real learning experience for us. One is in Bhutan when we're doing the rangeland mapping. Our satellite analysis showed that the rangeland health is growing because we see more greenness there. But when we went to the field, we found that it was due to the invasive species that has spread, and that is not palatable for the yak. So that means for the local community, the land is degrading, although we see more greenness in the area. So that knowledge is very important, that unless we can also identify the species that is growing, that is invading that area, our whole interpretation of land degradation or land restoration can be completely wrong. Another example is like in Nepal these days, a lot of these monkeys has been a big trouble for the farmers. And we have seen that many villagers are abandoning their agricultural fields, which are slowly taken over by shrubs and all those invasive species. And if you just rely on the remote sensing data or on satellite data, you will see that the land you might interpret that it is getting better. But in fact, if you really look at the ground, it is not so. So this ground truthing and then having the local context, local knowledge is very important to really have a better understanding. But it is also quite challenging because mountains, they have the variability is very high. within a very small distance, you can see a microclimate and all those affect a lot of these vegetation and others. At the same time, accessibility is also very difficult. So we cannot really do the extensive and kind of field work also. So that way, I think it's still a challenge if you really want to go and have a very accurate information on the ground. But still, like we need to have a kind of a compromise on up to what extent we can get from the satellite data and up to what extent we can really make it better by using the indigenous knowledge. Thank you.
Thank you so much. Tatender, if we could finish with you before we open up to the audience for some questions, maybe some reflections on the discussion. And I know that you're also working directly with UNCCD and parties and projects on the ground in different countries, and wonder how you think they can benefit from today's discussion, some of the things discussed here today.
Thanks a lot. Yeah, I think I can echo what Antje already just said. I think it's a good start. I mean, we can see there is knowledge available, and the knowledge that they actually request, a lot of it is already here without investing in inventing new tools and devices. So I really think we should start building on what is already existing, perhaps for other indicators, for other conventions, and to take this one and include it into the whole discussions. And also that we are aware there is this gap for mountain ear areas, and how can we address it? I think we have to take it serious, not only related to what kind of land degradation we have, but also what kind of options we have to avoid land degradation and to reduce. Again, often we now discuss about the hotspots, about what is red, what is degraded, what can be done there. But we also have to think about with the whole climate change situation. You mentioned it, or you mentioned the examples, you mentioned the glaciers that are melting. We face new problems as well, and that needs also action. And so we also have to consider, if we are calculating numbers on how much a project costs or implementation, we also have to consider the cost for inaction. So if we are not investing to avoid land degradation in future, we might face much bigger problems than we have already now, even it's not so obvious, it's not so easy to see with Earth observation images. So I think it's a good start to bring this expertise together, and I think we can continue these discussions then also at COP in Ulaanbaatar this summer.
Great, thank you. I'd now like to open up for questions, but before we do that, maybe a quick question. Who here is from the kind of mountain community, looking at mountains or researching mountains? Can you raise your hands? I know I am in mountains. There's nobody else here from the mountains apart from Alex. That's interesting. Who here is working on LDN? Is anybody here specifically working on LDN? 1, 2, 3. Okay. The rest of you are all along for the ride. That's good. Do we have any questions from the audience to the panelists? I think there's a lot of interesting things that have come up here today. Yep, over here.
Thank you. I had a question that was more related to the in situ component, because that's becoming more and more relevant, especially also for our global assessments with Earth observation, the need of really good, accurate and continuous in situ there. And it was quite interesting to hear about this, the GeoMountain in situ inventory. I would like to know a bit more how it really works. Is it something that Geo is more a connector? How is it collecting data? How is it maintaining data? How available are they? How are they eventually connected to other in situ networks within Europe, for example? Now there's, I don't know, just talking about Lucas over Europe. Is that connected to this? Thank you.
Sure. Alex, would you like to take that one?
Yeah, thanks a lot for your question. So the in situ inventory is basically we have this form online where people can register their stations, and we do an update, let's say once a year, maybe sometimes a bit more, and we incorporate all of the station from our networks. So we do advertise for the next release, for example, and all of the networks kind of participates and contributes to the in situ inventory. But we don't host the data in our in situ inventory. We really share the metadata, so then people can go and click on the station they are interested for and request. There is always the contact of the person, and they can request for the the data if they are available. Sometimes there is a link to find them online. Sometimes it's directly the contact person of the researchers. So it's not directly linked with Geo, but it is, of course, in the Geo Knowledge Hub. It is shared, and yeah, there is also some demo. I think I don't remember exactly what has been shared in the Geo Knowledge Hub, but I think there is also a demo share the paper on the data available there. And yeah, but it's basically really community inputs for this.
Thank you, Alex. Any other questions? Yes, over here.
Hi. My question is more about the definition itself. So you spoke about a lot of the definitions and the local definitions and local knowledge. How many indicators can we build upon these local definitions? Because the simplest one definition I have found is I don't have grassland for my cattle. So you build an indicator on grassland, but how simple can that become and how complicated we can make it? Thank you.
Is that directed to anyone in particular or just the whole panel? Over to you. If anyone wants to take that.
I don't know where to start. Perhaps you can help me. So I started thinking about, I forgot actually where to go exactly. So there are all these different indicators and all these different definitions, and you would like to hear how complicated this finally is to bring them together.
Just technically, for example, the definition of desertification, if I go straight to that, is literally land degradation based on human and climate change. Done. Which climate change? Which humans change? So is that the difference between each country that can face completely can mesmerize how different we can see these processes in the ground? So especially in mountains, that sometimes it's just a snow cover. It's that complicated, or the definition is my coup de grace.
No, there, yes. Well, actually, I also realized now how I brought it up. No, I fully agree there would be this definition on land degradation, what it means theoretically. But what you just mentioned, if you're going into the field, the reality looks different. Someone who is coming from a biodiversity angle might have a different understanding of land degradation. Invasive species, as an example, can be very green. On Earth observation, it does not qualified as land degraded area, but if you're going then into the area and you discuss it with the farmers, with biodiversity experts, you will realize, no, this is land degraded area. So I think there it starts that we generate a common understanding of what degraded land means with the existing baseline and the framework we have from the definitions. But from my point of view, perhaps you are not, you would contradict, but there is not this just one land degradation that we can actually quantify.
Yeah, maybe I also give it a try. Well, first of all, what do we need definitions for? I remember when I wrote my thesis, like many years ago, about desertification, because at that time UNCCD was focused on desertification, which is land degradation in semi-arid and arid areas. So to be very, very strictly complying with the definition, you would actually have to cut out land areas in certain countries because they are not arid or semi-arid, but they might be in the future with climate change. So it totally didn't make sense. So UNCCD, with its LDN approach, widened their definitions now, even though the convention itself doesn't change. I think this would be, you better don't touch the convention text. But de facto, they widened their definition through this land degradation neutrality approach. And in the end, so, and with these indicators, it's from the bottom. So do you speak from the bottom up or from the top down? I think this is different. So what does degradation mean to a farmer or to a rangeland manager, whatever, does definitely not comply to those 3 sub-indicators of SDG 15.3.1, but the purpose is also something different. So for the global monitoring, you want to raise awareness of the problem and have a rough indication of, is this problem decreasing, increasing, decreasing, how are the countries doing? But we are very much aware that those 3 global indicators are not enough to inform decisions on the ground. This is why we need those essential variables. And this is where it might meet the ground level. And we know from experience, also from GeoBon and GeoGlam, that when you start working on essential variables, I mean, it took them 4 to 10 years to define them, and you can get lost in it. So we have to find a pragmatic approach. What are the most important indicators for which kind of land use decisions, either on the planning level at the national government level or more on the local implementation level? That would be my try to get at that.
I think the question is a classical question about the definition of the degradation or desertification. If you take a look at from the academic research, I think there's no concerns about the definition, right? So from the perspective of the convention, you know, we need to measure the progress about the SDG, the indicators and the conventions. So we should define some of the basic concepts under the framework of the convention, then give some of the indicators. You should report these indicators. I think it's just like this. How much the indicator could meet the scientific the requirement? I think it depends on the purpose of your work. I think just like the indicator framework of the CBD, the post-2020 the framework, we could have the multi-layer the indicators framework. Someone is the mandate the indicator. You must report the rate indicators like these 3 sub-indicators. For the other indicators, you should based on the truth about your country's the situations. You could report the more indicators to meet the definition of in your mind about your countries. I think it's very important. That's my interpretation about the indicator the question, I think. Yeah, thank you.
I'll also add a little bit on this. Many times we end up defining the indicators, but again, not looking into the practical aspects. I think that is where we end up again struggling after we define the indicators. We have seen that most of the essential variables we define, but later on we struggle to see how we can really come up with those data sets to really monitor those indicators. And many times we end up using very coarse resolution data sets. For example, for many of those variables, we have to still rely on MODIS data. And if you really look at it, many small details in the mountains are lost. That's why we also need to be careful on up to what level it is really feasible to come up with those baselines and monitoring the changes over time when you define the variables. So I think that's where later on the analyst and when we do those assessments, then we really struggle a lot afterwards. But in the beginning, even the definition itself is many times very fuzzy. Sometimes we find that, and then that also ends up coming up with wrong interpretations and wrong information on the indicators. So on one hand, we want to define the indicators to be more clear on the real situation, but again, sometimes it gives the wrong impression or wrong information or wrong understanding when we try to use those without proper data sets to support those indicators. I think that's what my take on this. Thank you.
Thank you. Tender, I see you're eager to
very
comment.
small, because this morning we had this comment, I don't know, from in the previous session, that we also should think about how we communicate outside the room and to politicians. And I think even in here, we are not really convinced about the definitions we are using. And if we are thinking about how we communicate it, desertification in German, Wüstenbildung. If you think about you're discussing with your country in Switzerland or in Germany, I'm doing something on Wüstenbildung. you are lost. Nobody's interested at all. So then you have to start thinking about, okay, we're talking about land degradation, and even then it still might be difficult, and we have to go into very specific details what it actually means. So I think the wording as well, in addition to the definitions of the indicator, very much matters.
That sounds complicated. We are out of time. I'm not sure if there were any burning last questions, or you're always welcome to talk to the panelists or the presenters after the session. If there's no more questions, then we might end it here. And a big round of applause for our panelists and presenters. Thank you very much. And thanks, everybody. And I think we go to coffee break. Yes, thank you.